Now, what is the geometric approach to solving this question? Let's make a pause here. Okay, let's keep going. We can try in statement 1 to visualize what it means that the line passes through a certain point that has a horizontal position of -3. That means that according to the information we have, the point might be located on any part of the second quadrant or the third quadrant. Why? Because if -3 is here, then on this virtual vertical line, this dotted line we are drawing, are all the possible positions of the passing points -3, S, depending on the value S might take. Say, for example, that S represents a value that is highly positive. So our passing point would be over here. Now, if we visualize a line with a negative slope of -3, that is, this meaning a declination angle of more than 45 degrees. If we try to visualize this, we might come up with a line like this. Okay, this is kind of steep. Still, you see how, as S is very high, the positive intercept means a yes to the question. Okay, so if we decrease S gradually, we can find that the position of the line would also be such that it would determine horizontal intercepts that are getting closer to 0, although still positive. This would mean another yes for an answer. But S clearly has no defined or predetermined sign. So what would happen if S were negative? Then the passing point would be in the third quadrant, and a line with a negative slope of -3 clearly would have an x-intercept that is negative. So statement 1 alone is not sufficient. Now, in statement 2, we are given the sign of S. So that makes clear that whatever the value of S being just negative means that the passing point -3, S must be located somewhere over the third quadrant only. Let's imagine this is the passing point for line K. So now we don't have the slope of the line uniquely defined, but we still know that it has a negative sign, the slope. So we can try and visualize different lines with negative slope passing through that point. For example, it might be this, or perhaps a line with a negative slope that is not so steep. What about this? And if we make the slope softer and softer, we will notice that the x-intercept tends to move to the left. So the possible positions of this intercept will always be placed to the left of the horizontal position -3. They have to be always in this part of the horizontal axis. They can never be to the other side of -3, otherwise the slope would have to be positive. So here we have a clear and definite answer to the question. The x-intercept is not positive, is always negative. From this, we can visualize that the x-intercept is not only negative, but also always less than -3. So this means a no for an answer and the same conclusion. So you can see two interesting approaches, one completely algebraic, based on the properties of the equation of the line and inequalities properties. The other is a more geometrical approach, which relies heavily on your ability to visualize and represent different and alternative cases that the statements might yield in a graphic way, in such a way that you can be thorough in analyzing all possible cases. Well, we might say that doing the question purely on a geometrical approach takes a little more practice and experience with these kind of questions.